This is our practice tree and name is microstructural change during arc welding. The main objective of this practice is to evaluate the microstructural change that a welded steel experiences through the process of electric arc welding through the different zones that make up the welding cord. The materials and equipment that we are going to use is steel plates, electrode for welding, silicon carbide, and phonic resin. The equipment that we are going to use in this practice is safety equipment, welding machines, abrasive disc, mounting press for metallographic microscope, and Vickers durometer.
For this practice is to weld the two pieces of metal. Then we cut for having two samples, one with the weld part and one of the pure metal. Then we done all the process of metallography that we saw in the last semester, and we analyzed the different samples to know the difference of a weld part and a non-weld metal.
I'm going to relate the welding zones with the theoretical schemes that we saw in class, which are these ones. The first one is the initial prepare joint. After that, we have weld at the maximum temperature, with joint filled with feeder metal. And finally, we have the weld after solidification. And in this picture, we can see the results that we obtained in the practice. With the diagram that is open there, we can show the interaction between the heat source and the base metal, in which we have three regions, which are the fusion zone, the heat affected zone, and the base metal, which this will be the fusion zone and the heat zone. Here we're going to compare two zones, which is the welding zone and the not welding zone, which will be from here to here. In this part, we can see that it is uniform, and in the welding zone it is not. The structure changes, and this is because of the heat that we put, and then we have to let it cool at 25 degrees. And this will be the fusion zone and the heat affected zone.
To analyze the hardness of our material, we have four main parameters to take into account: voltage, welding speed, current, and electrode diameter. Those graphs show the effects of welding parameters on the hardness of the welded joint. And here we are going to relate the hardness of the analyzed areas to the structural changes caused by welding. For this part, we made Vickers test, and the results were with tables. We have Vickers, 100 Vickers of 221 against historical of 220. Without welding, the results were with tables to 160 and against the theoretical of 100.
Here we have the images of the metallographic results. The first one is with the welding part, and the second one is the sample of steel without welding. In the first images, we can see that we have more grains than this one. So this means that because of the number of grains, which is bigger than this one, the hardness will be bigger.
Both of our results, both the metallographic analysis and the Vickers test, we can conclude that the welded part has a bigger number of hardness, and we can justify this by observing our metallographic photos that show a number of grains higher in the welded part than in the normal steel part.
Advantage and disadvantage of welding process. Welded joints are more economical because less labor and less material is required. Complete rigid joints can be provided with welding process. Disadvantage. Defects like internal air pocket, slag inclusion, and incomplete penetration are difficult to detect. What type of structural change are expected in welded area? The affected zone suffer a structural change in the grain size, and it's a recommendation because of the...
I will explain how the mechanical properties of a material change when welding is applied. Welding parameters have significant effects on the mechanical properties. The increase in the arc voltage and welding current can result in increased hardness and decreased yield strength, tensile hardness, and impact toughness. The yield strength and the ultimate tensile strength of the joints decrease with increased voltage. However, increasing welding speed increases both the UTS and the yield strength of the welded joints. This behavior can be attributed to the fact that increased current and voltage means increase in the heat input which can create room for defect formation. The increased hardness may be due to electrode coating, which provide alloy addition to the weld depth. Now I will explain how does arc welding with coated electrode work. The coated electrode arc welding is a manual arc welding method where the heat necessary for the welding is generated by the arc formed between a coated wasted electrode and the workpiece. Electrodes tip, welding bath arc, and the areas of the workpiece near to the welding machine are protected against the hazardous impact of the atmosphere by the gases formed as a result of burning and separation of the coating material. The slag formed by the melted coating material provides additional protection for the melted welding metal in the welding bath. The additional metal, the filler metal, is supplied by the core wire of the wasting electrode and the metal dust in electrode coating in some electrodes. As a conclusion, I would like to add that doing this laboratory took a lot of time because of the processes that we needed for the samples. But it was worth the wait because when we saw and analyzed the differences between the sample and the sample with the welding, we found out really interesting results. And I think that it was one of the most interesting laboratory practices. As a conclusion, I would like to add that doing this laboratory took a lot of time because of the processes that we needed for the samples. But it was worth the wait because when we saw and analyzed the differences between the sample and the sample with the welding, we found out really interesting results. And I think that it was one of the most interesting laboratory practices.
I learned how to make an arc welding. Also, the parameters that are very important to have a better welding work. And finally, this practice is very useful for us because as a mechanical engineers, we have to have a better understanding of welding work in our industry.
So my conclusion is that in this practice I learned with more detail the welding process, which is one of the most important process that we are going to use in our careers because it is fundamental in the industrial level. And I also put in practice all the terms and knowledge that we saw in the previous subject.
I really like this practice because we could apply stuff learned from materials behavior into a more complex practice, and that I could learn how to weld properly with the help of the guys at this.
In this lab, we learned how the welding process affects the steels in the grain size and its structure when we do metallographic
With this practice, we saw that welding metals makes they lose their properties. So we have to avoid welding metals when we want some properties with this material.